In this video, we will continue to look at coordinate geometry. Now, we look at the question which says that find the equation of the perpendicular bisector of the line joining the points A, 1, 3 and B, 3, 9. So, in this question, we're asked to find the equation of the perpendicular bisector of the line joining the points A, 1, 3 and B, 3, 9. Now, while this is not a requirement, we'll just basically try to, represent these points and to basically get an idea of what the line looks like. Now, it won't be a plot, but just a rough, representation of the points and, of course, the line AB. So, if we were to basically put a rough pair of axes, x and y axes, so if we want the point 1, 3, so let's say this is the point A, which has coordinates 1, 3. We expect B, which has coordinates 3, 9, to be further to the right of A and upwards of A. So let me just call this point right here B. So this is a point B, and this would be the point 3, 9, right? So basically, this is our line AB. Right? So that is our line AB. Now this question, they want us to find the equation of the perpendicular bisector of the line joining the points A and B. In other words, they want us to find the equation of the perpendicular bisector of AB. Now, when we bisect a line, we basically cut it in two halves, which basically means that we must cut the line at its midpoint. So when we bisect a line, we cut the line at its midpoint. So because we want to find the perpendicular bisector of this line, that means we are going to actually have to find the midpoint of the line. So I'll label this point M, which we take as the midpoint of the line AB, right? Now, the perpendicular bisector of this line, of course, will pass through the midpoint M, and as expected, it will be perpendicular to the line AB. Right? So this is the midpoint M, and therefore the perpendicular bisector of the of any line will pass through the midpoint of the line and therefore will be perpendicular to the line. So there are two things, of course, that we need to find. We need to be able to find the midpoint of the line AB, and we also need to find the gradient of the line AB. So generally, in order to find the equation of a line, we need two things. We basically need a point on the line and the gradient of the line. In this particular case, the point that we need to find is the midpoint of the line AB, and we need to be able to find the gradient of AB in order to find the gradient of any line which is perpendicular to AB. So firstly, we'll go ahead and we'll find the midpoint M of AB. Alright, so once again, we have A, which is a coordinate 1, 3. So let's just write them here. So A has coordinates 1, 3, and we have B, which has coordinates 3, 9. Right? So we'll just call this coordinate x1, y1, and we call this x2, y2. And so therefore, the coordinates of the midpoint M, so the midpoint M will be equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. And that basically is how we find the midpoint of a line. So substituting these values now, we get that M is 1 plus 3. This is 1 plus 3, which is 4 over 2. And then we have 3 plus 9, which is 12 over 2. And therefore, M, the midpoint of AB, has coordinates 2, 6. So therefore, M, the midpoint of AB, is the point 2, 6. Now, having found the midpoint of M, we then need to find the gradient of the line AB. So the gradient of AB equals, so say y2 minus y1 over x2 minus x1. And of course, using these 2 points, then we see that the gradient of AB is going to be equal to 9 minus 3 divided by 3 minus 1. So this gives us 6 divided by 2, which is equal to 3. So the gradient of AB is equal to 3. But what we want to find is the equation of the perpendicular bisector of AB. So we already found the midpoint of AB, and now we need to find the gradient of the perpendicular bisector of AB. Now, from our knowledge of perpendicular lines, we know that basically if two lines are perpendicular, the product of their gradients is equal to -1. In other words, if two lines are perpendicular, the gradient of one line is the negative reciprocal of the gradient of the other, right? So in this case, if the gradient of AB is equal to 3, then the gradient of the perpendicular bisector of AB is equal to the negative reciprocal of the gradient of AB. So this is equal to -1/3. So once again, if two lines are perpendicular, the product of their gradient is equal to -1, or in other words, the gradient of one line is equal to the negative reciprocal of the gradient of the other, right? So now that we found the midpoint M, and we found the gradient of AB, and of course the gradient of the perpendicular bisector, we can then basically go ahead and find the equation of the perpendicular bisector of AB. Not AB, yes, gradient equation of the perpendicular bisector of AB. So what we're going to say is that we're going to be using the point. So using the point M. So M is of course 2, 6, and gradient -1/3. We can now say that basically we can do this one of two ways. We can actually find the intercept of the line and then put it in the form y equals mx plus c, or we may actually use the form y minus y1 equals m into x minus x1, right? Where of course in this particular case, x1, y1 would basically be the point that we have. So this in this case, in finding the equation of the line, this is going to be our x1, y1. So using this approach, we get that y minus 6 is equal to -1/3 times x minus 2, right? So we're asked to find the equation of the line. We weren't asked to find it in any particular format. So we could do one of two things. We could actually just expand these brackets on the right-hand side, or we could actually multiply both sides by 3 and get it in a particular form. It doesn't matter, right? So let's just expand the brackets on the right-hand side. We get that y minus 6 is equal to -1/3 x. Then we have -1/3 times -2. That gives us plus 2/3. And so therefore this becomes y equals -x/3 plus 2/3 plus 6. 2/3 plus 6. 6 of course is the same thing as 18/3. And so this gives us y is equal to -x/3 plus 20/3. And this of course is the equation of the perpendicular bisector of AB.